Okay, class. We're gonna look at inverse trig functions. I hope you guys worked on the exam. Um, all right, let's look at the inverse trig functions. Inverse trig functions. So for the inverse trig function, we're gonna look at sine, cosine, and tangent. Now, in order to be inverse trig functions, do you guys do you guys remember the in order for a function to be one-to-one, it has to pass the vertical line test. So if I'm looking at sine, and you can see it doesn't pass the vertical line test. Same as cosine too. If you draw cosine, cosine looks like this, doesn't pass it. A tangent doesn't pass it because it's periodic, so it doesn't pass. So how do we find sine inverse function, or cosine inverse function, or tangent inverse function? The way we go about doing that is we restrict them. So we look at, for the sine one, we look at from negative pi over 2 to positive pi over 2. And if I look at the graph of sine, it looks like that. And we just flip that. X becomes the y becomes the x. So it flips it. And it becomes like this. Oh, no, I got it wrong. Like that. And this becomes negative pi over 2, positive pi over 2, and so on. That's your sine inverse. So let me give you the restrictions for sine inverse. Y equals sine inverse of x and sine inverse lives in from negative pi over 2 to positive pi over 2. And it includes the two endpoints. It includes the two endpoints. So let's go back to this quadrant 1, 2, 3, and 4. If I do quadrant 1, 2, 3, 4, let me use this color for sine inverse. Sine inverse lives from negative pi over 2 to positive pi over 2. This is very crucial about where they live and things like that. Because what else do we know? All students take classes. So therefore, sine is positive in this quadrant and negative in this quadrant. That's where we use that. When we do the inverse functions, that's what positive and negative matters. For cosine inverse, it lives from 0 to pi. From 0 to pi. And what do we know about it? Cosine is positive over here, negative over here. That's very important. And for the tangent inverse, this is the little bit tricky one. Let's use this color. y equal tangent inverse, it lives from negative pi over 2 to positive pi over 2, but it will not include the two endpoints. So therefore, this is where tangent inverse lives in. Why we're looking at all that? Oh, by the way, when you're using calculator, make sure your calculator is in radian mode. If it's in degree mode, you're gonna get weird wrong answers. So why is that important? So let's look at this type of problem. I want to know sine inverse of 1/2. What is that? So another way of looking at that problem would be sine of what is that gives you 1/2, or in this case, what's that angle that gives you 1/2? Sine of what gives you 1/2? That's what we need to do. And then we could go back to the table. Do you remember that table? 0, pi over 6, pi over 2, pi over 3, and then pi over 2. So we use that, and we look at it for what angle you get 1/2. You get it at pi over 6, right over here. So right away you could say sine of pi over 6 is 1/2. It works. In this case, it kind of works because if I look back, sine inverse lives in first and the fourth quadrant, and pi over 6 is already in the fourth quadrant, so therefore it works. But what if it didn't live in the nice quadrant? How do you get all these different answers? So we're kind of working backward of the I give you an angle, give me the exact answer. Now you have the exact answer, you have to figure out the angle. What if we're doing something a little bit more interesting? Sine inverse of negative 1/2. What is that? So in other words, sine of what gives you negative 1/2? Well, if we use the table and so on, it's pretty simple. Since we're talking about negative, sine is negative in these two quadrants, and we're talking about inverse, so the angle has to live in this. So we got to figure out this angle. Now, in order to find this angle, there are several ways of doing that. You could get this blue angle or this orange angle. They will work the same. But because we're talking about sine inverse and they're strictly restricted to negative pi over 2 to positive pi over 2, the angle has to lie in that. So if the reference of this angle is pi over 6, and this big angle is going to be what? 11 pi over 6. That is actually correct. It's negative sine of 11 pi over 6 gives you negative 1/2. That is correct, but that's not the right answer when we talk about inverse trig functions. What that means is, what you have to do in this case, figure out this negative angle, or we call it coterminal angles. So this is very simple. It just goes to the negative side of that, and you get negative pi over 6. What if I give you a little bit harder problem? Like, cosine inverse of negative root 2 over 2. What is that? It's another way of looking at it would be cosine theta. So in this case, what we look at, cosine inverse lives at from 0 to pi. So it lives in this first quadrant and the second quadrant. Right now it's negative, therefore the angle is going to be in the third quadrant. So let's figure out the reference angle in this case. So cosine of what gives you root 2 over 2? Just a reference angle. Using that table, we discovered that theta equals pi over 4 gives you cosine of theta gives you root 2 over 2. Pi over 4. So that's the reference angle. So in this case, the reference angle would be pi over 4. But is that my appropriate answer? No, it's not, because it's 0 to pi. So in this case, what's the measurement of this actual angle? If this is pi over 4, this is going to be 3 pi over 4. So your final answer is going to be theta is equal to 3 pi over 4, which lives inside 0 to pi. Okay, good. Now, let's do another one. Tangent inverse of negative root 3. So tangent inverse lives in first and second quadrant. So we're looking at tangent of theta equals negative root 3. So we're looking at negative angle right over here. Boom. So this is the reference angle. So if we use the table right away, the reference angle we get to be pi over 3 right away. But does pi over 3 live inside negative pi over 2 to positive pi over 2? And it lives on the fourth quadrant? No. Pi over 3 lives in the first quadrant. So how do I get this actual angle that lives in the fourth quadrant? Again, it's a coterminal angle. It's going negative, so it's going to be negative pi over 3. So that's your final answer. I think that should be it. Let me see. So this section, I'm making it very simple. As you have noticed, I did not assign 7.1D on tomorrow. We're gonna do a lot more of this stuff when we come back. So the exam is due today. Make sure you get all the exam, everything done. All right, guys, I'll see you guys next time. Thank you.